Hello, welcome to section 3.3, the derivatives of trigonometric functions. So today we're going to look at our basic trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, and identify their derivatives. So we're going to look at the graph of the sine. This is the sine curve. You know, it goes on forever in both directions, but we can see that it's periodic. It repeats itself every 2 pi, right? And it goes on forever. So what I'm going to do, just to give you, maybe sort of convince you what the derivative of the sine curve is by graphing the graph of the derivative of the sine without identifying it. So what I'm going to do is I'm going to go to certain points on this curve. For example, if I'm standing right here on this curve, right here at about, I don't know, looks like that's 3.14, so that's pi, so that's about halfway. So pi over 2 right here, the derivative is 0. If you're standing right here at the top of the hill or the bottom of the valley, so all of these tops of hills and bottoms of valleys, the derivative is going to be 0. So the value of the derivative here, 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 and here is all 0. Because remember, that's what the derivative is. We're sketching the graph of the derivative, so I'm looking at each input and I'm deciding what is the steepness at that point. All right, I'm going to go over here for a minute. Let's look at 0. Now remember, 45 degrees has a slope of 1. That looks pretty like a 45-degree angle. So I'm going to conclude the derivative at 0 is 1. Now notice if I'm here at the middle of this curve, if I go over 2 and down 2, so here my slope was 1. I went over 2 and up 2, so the slope was 1. Here my slope would be -1. So if you're standing right here on the curve, which is a little beyond 3, the steepness is about -1, which is like right here. So likewise, if I'm standing here also, right, it doesn't matter what the output of the original curve is. Remember, we're plotting what the derivative is. So if you're standing right here, it's the same steepness if you're standing here. So I'm going to conclude the steepness over here is also about -1. Right, so do you see a pattern here? Right, so as we go between, if we start here at 0 and we move towards 2, our slopes are getting less and less steep. So our slopes are decreasing. They're behaving like this. Right, and then they start increasing and getting more and more negative until they hit this point, and then they start becoming less and less negative like this. So if I was to just take a rough sketch of the graph of the derivative of the sine curve, notice, does this look like something familiar? Right. It is the cosine curve if that's what you said. So that being said, we can conclude that the derivative of the sine curve is the cosine curve. For y equals the sine of x, the derivative is the cosine of x. For the proof of this, using the limit definition of the derivative, that's left to the reader. It's in your textbook. So here we go, corny cloud. You are going to just memorize this. I will never ask you to prove that the derivative of the sine curve is the cosine curve, but you are expected to remember it. All right, let's look at the graph of the cosine. So here is the graph of the cosine. All right, now let's suppose I did the same thing and I said, let's draw the graph of the derivative. So here, if we're standing right here on the cosine curve, so this is y equals the cosine of x. If we're standing right here, here, or here, right, the derivative is all 0. So corresponding derivative graph, well, here, the derivative would be 0. Here, the derivative would be 0. Here, the derivative would be 0. Down here, the derivative would be 0. Here, the derivative would be 0. So now I'm going to go identify where the slope is 1 or -1. Well, notice right here, right about here, right where that dot is, the slope is about +1. So if I go down here, it's about right here. I'm going to say that's the derivative right here. At these 2 points, right here and right here, the slope is -1. So about right here, we're going to have the derivative -1. Here, we also have the derivative -1. Right here. Right. And then if we're here, we have a steepness of about 1 again, a little bit 4 or 5, beyond 5, maybe about right here. Right. Now, if you notice, we connect these dots, and this itself is again a periodic wave, although it's not quite the sine function, because the sine function, when we start at the origin, it starts by going up and then goes down. Here, this goes down and then goes up. So this is a form of the sine function. This is the sine function flipped upside down. And as a matter of fact, for the function y equals the cosine of x, the derivative is the negative sine of x. So the derivative of the cosine is the negative sine. The derivative of the sine is the positive cosine. All right, so remember this. Again, for more details, it's in your reading. It's also in the PowerPoint presentations. All right, function, sine x, derivative is the cosine of x. For the function cosine, the derivative is the negative sine of x. Well, what about the tangent, cosecant, secant, and cotangent? Well, once you know these two, the four follow from rules that we've talked about previously. Well, the derivative of the tangent is the secant squared. How and why? Well, notice. Y is equal to the tangent of x is equivalent to saying the sine of x over the cosine of x. Now we know the derivative of the sine, we know the derivative of the cosine, and we know the quotient rule. So if we apply the quotient rule and call the tangent sine over cosine, we get the secant squared. Ready? Watch. The derivative of the tangent is the derivative of the top, the derivative of the sine is the cosine, times the plain old bottom, minus the plain old top, times the derivative of the bottom, and the derivative of the cosine is the negative sine. And that's all over the bottom squared. All right, well, let's clean this up. Cosine times cosine is cosine squared, minus sine times negative sine will be plus sine squared, all over cosine of x squared. But cosine x plus cosine squared plus sine squared is 1 over the cosine of x squared. But algebraically, this is equivalent to 1 over the cosine of x squared. If we distribute the power, we get 1 squared over cosine squared, which is 1 over cosine squared. But 1 over the cosine is the secant. So this is just the secant of x squared, which we just write it like this. This is just a notation thing. The squared in here is just so we don't mistakenly square the x. This says take the secant of this value and then square the result. So the derivative of the tangent is the secant squared. All right, derivative of the cosecant is the negative cosecant of x times the cotangent of x. How can we find that? Well, remember, the cosecant is 1 over the sine of x. So if you took the derivative of 1 over the sine of x using the quotient rule and simplifying it using your trig identities, you would get negative cosecant of x times the cotangent of x. The derivative of the secant is the secant of x times the tangent of x. And the derivative of the cotangent is the negative cosecant squared of x. We could find this derivative from the secant by thinking of the secant as 1 over the cosine and using the quotient rule and getting this. The cotangent is the cosine over the sine. If we applied the quotient rule to cosine of x over the sine of x, the derivative would be negative cosecant squared. So again, these can all be proved using limit definition of the derivatives, or accepting that the derivative of the sine is the cosine and the derivative of the cosine is the negative sine, and then using the quotient rule for the tangent, cosecant, secant, and cotangent by writing them as quotients involving sines and cosines. However you want to do it, I suggest you just remember them, especially if you're going on to Calc 2. You want to be proficient, you want to know your derivatives, okay? One little side note, if a function starts with c, a trig function starts with c, notice its derivative is negative. I don't know, I just always remembered that. trig functions that start with c's have negative derivatives. If it doesn't start with c, like the sine, the tangent, and the secant, the derivatives are positive. So you are expected to remember these. All good calculus students know the derivatives of their trig functions. All right, so all the rules from 3.1 and 3.2 apply to our trig functions. So let's suppose you were asked to find the derivative of y equals x squared over the secant of x. We have a quotient. There's nothing we can do to simplify this algebraically, so our only option is to use the quotient rule to find this derivative. And the derivative of a quotient is a quotient. Immediately draw your fraction bar. The derivative of the top is 2x times the plain old bottom, secant of x, minus plain old top, times the derivative of the secant, and the derivative of the secant is the secant of x, tangent of x, all over the bottom squared, secant of x squared. Now this isn't incorrect, but we're definitely can factor and do some canceling here. Notice the numerator shares, the terms in the numerator share an x and they share a secant, so I'm going to pull an x and a secant out. And what's left is 2 minus, well, I took just the x and the secant out, so it's x and the tangent are left in the second term. And just for simplification, I'm going to call the secant squared, the secant times the secant. So then maybe you can see clear that these are going to cancel out. And then what I'm left is I still have that x. Don't lose that guy. We only canceled out the secant in the numerator. 2 minus x, tangent of x, all over just one secant. There we go. All right, one more. Let's find the derivative for the sine squared of x. Now this is, I put this in here because it is a notation thing. You have to be really super careful. The sine squared of x means the sine of x squared, which means the sine of x times the sine of x. So f of x is really just the sine of x times the sine of x. That's what that notation means. So the derivative, we're going to apply the product rule. Whenever we have a product, the product rule says, take the derivative of the first function times the plain old second plus the plain old first times the derivative of the second. So the derivative of sine squared of x, which is equivalent to the derivative of the sine of x squared, which is the same as the derivative of the sine of x times the sine of x, is the cosine of x times the sine of x plus the sine of x cosine of x. But notice this is the same thing because we can switch the order in which we multiply. So I'm just going to rearrange this first term and I'm going to call cosine of x times sine of x, sine of x times cosine. So we have one sine of x cosine of x plus another sine x cosine of x. So in that case, I have 2 sine x cosine of x's. And that would be the derivative of the sine squared. All right, have fun. You want to be really good at taking derivatives. Once we get out of chapter 3, it's going to be assumed that you're comfortable with the templates of derivatives and you want to be able to do these quickly. The way to get to the point to do these quickly is by taking lots of derivatives. So make sure you're doing your homework online if you have online homework, and also as many problems as you can do in the book, okay? All right, enjoy.